Why do we, as a species, so readily dismiss scenarios that, while extreme and perhaps statistically improbable, are undeniably rooted in scientific possibility? We spend countless hours discussing the threat of asteroid impacts, meticulously tracking celestial bodies that could spell disaster, and we dedicate entire scientific fields to understanding supervolcanoes, their potential to plunge the world into a nuclear winter. Yet, when the conversation turns to something as monumentally destructive, as fundamentally universe-altering, as a black hole, the silence is often deafening. It's a topic that barely registers beyond the realm of science fiction, relegated to the fantastical, almost as if acknowledging its remote possibility would somehow invite it. Is it because the implications are simply too inconvenient, too destabilizing for the comfortable narratives we construct about our planet's enduring safety and our place within the cosmos? Perhaps the idea of an object so alien, so utterly beyond our control, passing through our world challenges our deepest assumptions about permanence and resilience. Here, we don't just explore the what-if. We question why some what-ifs are kept out of the public conversation, why certain cosmic dangers are deemed too out there to warrant serious consideration, even as a thought experiment. Today, we dive into one of those unthinkable what-ifs. What if a black hole passed through Earth? The very phrase conjures images from blockbuster movies, dramatic special effects, and heroes valiantly, yet futilely, fighting against an unstoppable force. But let's strip away the Hollywood veneer for a moment. Black holes are not merely figments of a screenwriter's imagination. They are established astrophysical phenomena, cosmic behemoths, whose existence is backed by decades of rigorous observation, mathematical prediction, and groundbreaking discoveries. From the detection of gravitational waves to the stunning images captured by the Event Horizon Telescope. They are real, they are plentiful, and they are, in their purest form, regions of space-time where gravity is so intense that nothing, not even light, can escape. The universe, as we know, is vast beyond human comprehension. The distances between celestial objects are staggering, measured in light years, making the prospect of any two objects colliding seem astronomically small. The chance of a black hole, specifically, encountering our tiny blue marble in this immense cosmic ocean is indeed incredibly low. But incredibly low is not zero. And this small, non-zero possibility is precisely what makes the question so compelling, and perhaps so unsettling. So, why is this scenario, unlike its asteroid or supervolcano counterparts, so rarely discussed seriously, even as a theoretical exercise in planetary defense or cosmic risk assessment? Why does it feel almost taboo to consider the ramifications of such an event with the same gravitas we apply to other existential threats? Is it because it challenges our fundamental assumptions about our planet's presumed resilience, our technological limitations, and ultimately our fragile, fleeting existence in the grand cosmic scheme? The discomfort it evokes might stem from the realization that, against such a force, all our human ingenuity, our scientific prowess, and our collective will might be utterly, tragically impotent. It forces us to confront a level of cosmic vulnerability that we are perhaps simply not equipped to process, let alone plan for. This reluctance to seriously engage with the idea of a black hole passing through Earth might be less about scientific probability and more about psychological coping mechanisms. This reluctance to seriously engage with the idea of a black hole passing through Earth might be less about scientific probability and more about psychological coping mechanisms. This then leads us to the heart of the matter. Where does the idea of an Earth-black hole collision even come from? And why is it so consistently sidelined in serious scientific discourse? The concept isn't entirely new, nor is it born from pure fantasy. The seeds of such hypotheses can be traced back to the early days of astrophysics, when scientists first grappled with the implications of gravity, stellar evolution, and the bizarre objects predicted by Einstein's theory of relativity. Long before black holes were directly observed, their theoretical existence hinted at cosmic scenarios that stretched the imagination. Early conjectures about cosmic impacts often focused on more mundane, though still devastating events like asteroid strikes. Yet, the logical extension of these thoughts, especially as the concept of collapsed stars gained traction, naturally led to increasingly extreme what-ifs, including the potential interaction with these enigmatic gravitational monsters. Who then dares to raise this unsettling concept? Occasionally, you'll hear it from fringe physicists, those operating on the speculative edges of theoretical science, eager to explore every conceivable implication of the universe's most extreme phenomena. Science fiction authors, of course, have long embraced the dramatic potential of black holes, weaving tales of cosmic destruction and survival that captivate audiences. But critically, you rarely hear this topic discussed by mainstream science communicators or official scientific bodies with the same earnestness reserved for, say, climate change or pandemic preparedness. It's often relegated to the realm of thought experiments so improbable they barely warrant a second glance. And this brings us to the crucial question: why is it so often ridiculed or dismissed as sensationalist, absurd, or even irresponsible by official channels? Part of it, undoubtedly, is the incredibly low probability. Scientists are trained to focus on scenarios with a higher likelihood of occurrence, where research and resources can be most effectively allocated. However, there's also a deeper, more subtle dynamic at play. Labeling such scenarios as too extreme serves a powerful psychological function. It provides a comforting barrier, a mental firewall that prevents deeper, more unsettling thought about our true cosmic vulnerability. To seriously entertain the idea of an Earth black hole encounter would necessitate confronting a level of cosmic chaos that is almost impossible to mitigate or control. It challenges our inherent human need for order, predictability, and a sense of mastery over our environment. This dismissal isn't necessarily a malicious conspiracy, but rather a collective, perhaps subconscious effort to maintain a sense of stability. Official narratives tend to emphasize solvable problems, threats that can be understood, measured, and potentially countered through human ingenuity. A black hole passing through Earth, on the other hand, represents the ultimate unsolvable problem, a force of nature so overwhelming that all our technological advancements and societal structures would be rendered utterly meaningless. It's a narrative that undermines the very foundations of human agency and progress. Therefore, it's easier, and perhaps more psychologically beneficial for societal cohesion, to simply push such a scenario to the furthest fringes of possibility, to categorize it as science fiction, rather than a remote but real astrophysical possibility. This tendency to sideline the truly catastrophic, the utterly uncontrollable, reveals more about our collective psychological comfort zones than it does about the actual likelihood of the event itself. We prefer to focus on threats we can, however tenuously, imagine ourselves surviving or overcoming. But what would truly need to align for such an unthinkable event, to transition from a theoretical musing to a terrifying reality? The conditions required for a black hole to pass through Earth are far more nuanced than a simple collision. It's not just about a cosmic bullet meeting a planetary target. It involves a delicate dance of celestial mechanics, and crucially, the specific nature of the black hole itself. When we talk about black holes, we often lump them into one terrifying category, but they exist on a spectrum. We have stellar mass black holes, typically formed from the collapse of massive stars ranging from a few to hundreds of times the mass of our Sun. Then there are the behemoths, supermassive black holes, residing at the centers of most galaxies, including our own Milky Way, with masses millions or even billions of times greater than the Sun. However, for an Earth encounter, neither of these is the primary concern for a direct traversal. The real, albeit still incredibly remote candidate for such a terrifying journey through our planet is the primordial micro-black hole. These hypothetical objects are theorized to have formed in the extremely dense conditions of the early universe, moments after the Big Bang, rather than from stellar collapse. Their sizes could vary immensely, but the ones relevant to an Earth impact scenario would be far smaller than typical stellar black holes, perhaps even subatomic in scale, yet still possessing significant mass. A micro black hole with the mass of a large asteroid, for instance, could be no larger than an atom, making it practically invisible until its gravitational effects became catastrophically clear. For such an object to interact with Earth, several specific characteristics would be paramount. First, its size. A micro black hole would be small enough to pass through our planet without completely devouring it in an instant, unlike a stellar mass black hole, which would likely consume our entire world. Second, its velocity. It would need to be traveling at an immense speed, perhaps a significant fraction of the speed of light, allowing it to traverse the Earth's diameter in milliseconds. This velocity is crucial because it dictates the duration of the interaction and the extent of the gravitational disruption. A slower-moving black hole, even a tiny one, would spend more time interacting with Earth's matter, leading to a much more destructive outcome. Third, and perhaps most obviously, its trajectory. A direct path through Earth's core would be the most impactful, but even a glancing blow could have devastating consequences. Simplified explanations often present space as a vast empty void, making the idea of two objects colliding seem astronomically improbable. And statistically, it is. However, this simplification misses the actual density of cosmic objects, particularly in certain regions of space, and the sheer number of primordial black holes that could theoretically exist, even if they are incredibly rare. The universe, despite its vastness, is not uniformly empty. Our solar system, for example, resides in a galactic neighborhood that is far from sterile. While the probability remains infinitesimally small, it's not zero. Furthermore, we often overlook the nuances of gravitational interactions that extend far beyond a simple pull. A micro black hole wouldn't just pull Earth towards it. As it passed through, it would exert immense tidal forces, distorting the planet's shape, creating colossal seismic waves, and potentially ripping apart its internal structure. The immense gravitational gradient across Earth's body as the black hole traversed it would be unlike anything our planet has ever experienced or is capable of withstanding. It wouldn't simply be a hole punched through, it would be a catastrophic internal seismic event. A planet-wide shudder that could tear our world asunder from the inside out. Understanding these specifics moves the discussion from mere science fiction to the realm of extreme, albeit improbable, astrophysical mechanics. The simple "what if" quickly becomes a terrifyingly complex cascade of physical phenomena, each more destructive than the last. Unforeseen consequences beyond the obvious. The immediate visceral image of Earth being swallowed whole by a black hole, while dramatic, often overshadows a terrifying truth. The indirect, systemic impacts would likely be far more insidious and widespread, triggering a chain reaction of global collapse long before any direct consumption. We tend to fixate on the spectacular, ignoring the quiet, creeping dread of cascading failures that would dismantle our interconnected world piece by piece. Consider the immediate aftermath of a micro black hole's passage. Even if it merely threaded through Earth's mantle without fully consuming the planet, the gravitational stresses would be monumental. Seismic activity would not be localized to a single fault line. It would be global. An instantaneous planet-spanning earthquake of unimaginable magnitude. Every tectonic plate would buckle. Every mountain range would shudder. Every ocean basin would roil. Tsunamis of unprecedented scale would scour coastlines, not from a single point of origin, but from multiple simultaneous ruptures across the ocean floor. Cities would crumble into dust. Infrastructures designed for incremental stresses would simply disintegrate under such an all-encompassing shockwave. Beyond the physical destruction, the Earth's magnetic field, our planetary shield against harmful solar radiation, would be catastrophically disrupted. This field is generated by the churning molten iron in our outer core. A micro-black hole tearing through this delicate dynamic system would create an instantaneous and violent perturbation, potentially collapsing the field entirely or rendering it unstable. Without our magnetosphere, Earth would be exposed to the full fury of the solar wind and cosmic rays. Not only would this pose an immediate radiation hazard to all life, but it would also strip away our atmosphere over time, turning our vibrant blue planet into a barren Mars-like wasteland, albeit over a longer time scale than the initial impact. The very air we breathe would be affected. The immense energy transfer from the black hole's passage, coupled with global volcanism and atmospheric shockwaves, could trigger superheated plasma events in the upper atmosphere, or even ignite atmospheric components, creating firestorms visible from space. The delicate balance of atmospheric gases, essential for life, would be irrevocably altered, leading to suffocating conditions, radical temperature swings, and unprecedented weather phenomena. And then, the cascading failures across our global nervous system. Our modern civilization is built on an intricate web of electricity, communication, and data. Power grids, reliant on stable infrastructure, would fail instantly and irrevocably. Satellites, crucial for GPS, internet, and global communication, would be knocked out of orbit by the gravitational anomaly or rendered useless by the magnetic field collapse and subsequent radiation storms. The internet, the lifeblood of our informational age, would cease to exist. Global supply chains, already fragile, would fracture completely. Food distribution, medical supplies, energy resources, all would halt, plunging billions into a desperate struggle for survival without the basic necessities. The human, political, and institutional responses to an event perceived as impossible would be equally catastrophic. Panic would be absolute, denial widespread, and the breakdown of social order inevitable. Governments, designed to manage predictable crises, would be overwhelmed by a scenario that defies all precedent. Who would take charge? What orders would be given? How do you coordinate a response when the very means of communication have been obliterated? The sheer scale of the event would render all existing emergency protocols obsolete. The perceived impossibility of such an event means no contingency plans exist. It would not just be the end of the world as we know it, but the end of our ability to even comprehend it, leaving humanity adrift in a sea of chaos and despair, a testament to our hubris in believing we understood the full spectrum of cosmic threats. In the immediate aftermath of such an unthinkable cosmic intrusion, the political implications would be nothing short of revolutionary. Global governance, already a complex and often fractured tapestry of competing interests, would face an existential challenge. Emergency powers, typically reserved for localized disasters or limited conflicts, would be insufficient to address a planetary catastrophe. The scramble for survival would quickly devolve into a brutal competition for rapidly dwindling resources. Nations would turn inward, borders would harden, and the illusion of international cooperation would shatter under the weight of sheer desperation. Resource allocation would become a zero-sum game, with powerful states hoarding what little remained, while weaker nations and their populations faced oblivion. The very concept of global citizenship would evaporate, replaced by a primal struggle for local dominance and access to potable water, shelter, and sustenance. Economic interests, the very engine of our modern world, would collapse instantaneously. Stock markets, digital currencies, and even traditional banking systems would cease to function. The intricate global supply chains, already on the brink, would not just fracture but disintegrate entirely. Money, in any form, would become meaningless. Barter economies might emerge in localized pockets, but without a functioning infrastructure for production and distribution, even these would be temporary and incredibly fragile. The scramble for survival would give rise to black markets of unprecedented scale and ruthlessness, where essential goods would be traded for unimaginable prices, often at the point of a gun. Those who controlled the last vestiges of food, medicine, and clean water would wield absolute power, creating a new, terrifying hierarchy born from chaos. Crucially, in such a scenario, the control of information would become the ultimate weapon. Even as communication systems frayed and failed, any remaining means of broadcasting or sharing news would be fiercely contested. Governments, or what remained of them, would undoubtedly attempt to manage, censor, or spin the narrative to maintain some semblance of order or to serve their own survival agendas. The truth about the black hole's passage, its immediate and long-term effects, and the true extent of the devastation would be a carefully guarded commodity. Disinformation and propaganda would flourish, sowing confusion and further dividing already terrified populations. Who would gain control of the narrative? Those with access to the last operational satellites, the most resilient data networks, or simply the loudest, most compelling voice in the ensuing darkness? In this existential crisis, knowledge itself would become currency. Scientists, engineers, and specialists who understood the remnants of technology, the lingering effects of the event, or even just basic survival techniques, would suddenly find themselves invaluable. They would be sought after, protected, or perhaps even exploited, their expertise becoming a critical asset in a world stripped bare. The knowledge of how to purify water, how to grow food in contaminated soil, how to generate even rudimentary power, these skills, once taken for granted, would become the keys to survival and the foundation of any potential future society. The power structures that emerged from this cataclysm would be unlike anything humanity has ever known. The traditional levers of power, military might, economic wealth, political influence, would be rendered obsolete. Instead, power would gravitate towards those who could provide basic necessities, those who could offer protection, and those who could control the flow of information, however fragmented. Warlords, self-proclaimed leaders, and even cult figures might rise from the ashes, exploiting the desperation and fear of the survivors. This isn't merely a thought experiment about physical destruction. It's a profound examination of how human society, with all its intricate systems and hierarchies, would unravel when confronted with an event that defies comprehension and control. It exposes the fragility of our collective agreements, our shared realities, and the very narratives we construct to make sense of our existence. In the face of a micro-black hole, the true nature of power, control, and survival would be laid bare, revealing a terrifying glimpse into the abyss of human nature itself. The terrifying glimpse into the abyss of human nature, exposed by such an unimaginable catastrophe, would mark the breaking point. This is where a theoretical "what if" ceases to be a mere intellectual exercise and transforms into a dangerous reality, too significant, too immediate, to ignore. The transition from a distant, abstract threat to an imminent, undeniable one would unfold with a terrifying speed, forcing humanity to confront its deepest fears and its most profound vulnerabilities. Initially, the signs would be subtle, almost imperceptible to the untrained eye, dismissed as anomalies or statistical outliers. Scientists, however, would be the first to sound the alarm, their instruments picking up faint, yet undeniable, evidence. Gravitational lensing, the bending of light around a massive object, would be one of the earliest indicators. Distant stars and galaxies would appear to shift, their light distorted in ways that conventional astronomy couldn't explain. These initial observations, perhaps from remote observatories or space telescopes, would spark intense debate within the scientific community. A frantic race to understand the perplexing data before the public was alerted. As the micro-black hole drew closer, its influence would become more pronounced. Orbital perturbations of planets and asteroids within our solar system, however slight, would provide further, more concrete evidence. Satellites, our eyes and ears in space, might drift inexplicably from their predicted trajectories, their delicate instruments registering unusual gravitational tugs. Gamma-ray bursts, short-lived but incredibly powerful explosions of energy, could erupt from unexpected regions of space, signaling the black hole's interaction with interstellar dust or other celestial bodies. Each piece of data, painstakingly collected and analyzed, would build an increasingly chilling picture, transitioning from theoretical possibility to impending doom. The moment of public revelation would be catastrophic in itself. Imagine the global paralysis, the collective gasp of disbelief, as the world grappled with an enemy it could neither comprehend nor fight. The initial response would likely be a mixture of denial, panic, and frantic, disorganized efforts. Governments, already weakened and fractured by the preceding chaos, would struggle to disseminate accurate information, let alone coordinate a meaningful global response. The sheer scale of the threat would overwhelm existing emergency protocols designed for earthquakes, tsunamis, or even nuclear conflicts, not for a cosmic intruder. The scientific community, once a beacon of reason, would find itself at the forefront of a global crisis, burdened with the impossible task of explaining the inexplicable and predicting the unpredictable. Their warnings, once dismissed as sensationalist, would now be met with a desperate, often irrational demand for solutions. Yet against a micro-black hole, there are no solutions in the conventional sense. No weapon can destroy it, no shield can deflect it. The only option would be to understand its trajectory, its effects, and to prepare for the inevitable with whatever limited means remained. This is the intellectual and emotional climax, the moment the hypothesis demands our full, uncomfortable attention. The abstract concept of a black hole, once confined to astrophysics textbooks and science fiction, would manifest as an undeniable, terrifying reality. The existential dread would be palpable, infecting every corner of human society. The questions would shift from if to when, and from what if to what now. The very fabric of society would begin to fray under the immense psychological pressure. Trust in institutions would crumble as their inability to cope became starkly evident. Social norms, laws, and ethical considerations would be challenged by the primal instinct for survival. The transition from a distant, abstract threat to an imminent, undeniable one would be the ultimate test of humanity's resilience, exposing the raw, unvarnished truth of our collective fragility. The world would hold its breath, not knowing whether to fight, flee, or simply wait for the end. The scientific consensus, when pressed, often skirts the true implications of such an event. They will meticulously calculate the vanishingly small probability of a black hole encounter, citing the vast emptiness of space and the precise conditions required for such a cosmic alignment. They will reassure us that our solar system is a relatively stable, well-understood neighborhood, and that any rogue object of significant mass would be detected long before it posed an immediate threat. This consensus, while scientifically sound in its statistical probability, often overlooks the uncomfortable truth that probability is not impossibility. It's a narrative designed to soothe, to maintain a sense of order and control in a universe that is fundamentally indifferent to our existence. The unpalatable truth is that such an event, however infinitesimally improbable, exposes the profound fragility of our existence. It lays bare the limits of our control, demonstrating that even with our most advanced technology and scientific understanding, there are forces in the cosmos against which we are utterly powerless. We can predict the weather, launch satellites, even land rovers on Mars, but we cannot deflect a black hole. This realization is deeply unsettling because it shatters the illusion of human mastery over our environment, an illusion carefully cultivated over centuries of scientific progress and technological triumph. This idea challenges existing power structures because it posits a threat that transcends national borders, economic systems, and political ideologies. A black hole doesn't care about GDP, military might, or stock market fluctuations. It renders all human constructs of power and wealth utterly meaningless. How do you maintain control when the very ground beneath your feet is being torn apart by an invisible force? How do you enforce laws or collect taxes when the concept of a nation itself is dissolving? The economic models that drive our world, built on predictable growth and stable resources, would collapse into irrelevance. The collective sense of security, built on the assumption of a stable planet and a predictable future, would evaporate, leaving behind only raw existential dread. The implications for humanity's future and our understanding of cosmic vulnerability are profound. Such an event would force a radical reevaluation of our place in the universe. We often view ourselves as the pinnacle of evolution, the dominant species on a planet we are slowly but surely shaping to our will. A black hole encounter would brutally remind us that we are but a speck of dust in an unimaginably vast and often hostile cosmos. It would necessitate a shift from anthropocentric thinking to a more humble, ecocentric, or even cosmocentric perspective. It would highlight the desperate need for planetary unity, for a collective human response to threats that affect us all, regardless of our perceived differences. Perhaps the ultimate lesson isn't really about black holes at all. It's about the narratives we choose to believe and those we conveniently choose to ignore, simply to maintain our fragile sense of order. We build elaborate economic systems, political hierarchies, and cultural norms, all predicated on the assumption of a stable, predictable reality. But what happens when that reality is fundamentally challenged by something utterly outside our control, something that refuses to fit into our tidy narratives? The dismissal of scenarios like a black hole passing through Earth isn't just about scientific probability, it's about psychological comfort. It's about protecting our collective delusion of control, our cherished belief that we are somehow immune to the universe's more violent whims. To truly confront such a possibility is to admit our own profound vulnerability, to acknowledge that our existence is a precious, fleeting anomaly in a cosmos that cares nothing for our hopes or fears. And that perhaps is the most terrifying truth of all.